Today, I will be talking about how to infuse ICT into inquiry-based learning. I am passionate about inquiry-based learning, and I think it is crucial to implement in every course because it allows students to discover and build connections on their own, developing high levels of critical thinking. In my teaching, I like to focus on the SAMR technology integration model, specifically using it to transform learning and do tasks that wouldn't be possible without technology. This way, students can build deeper conceptual understanding. My subject of specialty is math, and there are many resources that I think we can use to incorporate in support of inquiry-based learning. One example of that would be to highlight the grade 12 pre-cal curriculum where students are expected to graph and analyze trig functions, such as sine, cosine, and tangent. And the prior knowledge that students would have is the understanding of the unit circle. This is often a really difficult topic for students to understand. A lot of students struggle with imagining a circle being translated into a sinusoidal curve and how that can be translated into a general equation. Solely explaining these concepts using notes doesn't provide sufficient scaffolding for students to grasp this concept. Therefore, it's crucial that technology and simulations be used to help students understand. When technology is combined with inquiry-based learning for this outcome, students are able to have a deeper understanding and are more likely to remember it. This allows me to modify my pedagogy and redesign a task centered on the topic that students are able to understand. In this specific outcome, I would use the resources PhET, Interactive Simulations, and Desmos. So I'm going to take you on a quick tour of how to use them to teach this specific outcome. This PhET simulation is called Trig Tour. And so as you can see, as I move the point around the circle, students can see how the graph is constructed at the bottom. In the classroom, I would have the students each log on and play with the simulation and the curve. This way, they can come to conclusions on their own and build connections from the circle to the graph. You can even find specific values on our graph and how it translates to the circle, going in the opposite direction as well. For the second part of this, I would have the students log on to Desmos to do the marble slide periodics activity. Desmos is a powerful online graphing calculator and helps students build connections because they can instantly see changes in the graph when they manipulate values. So this game is called Marble Slide. So if we look at here, so what students have to do is they have to manipulate this curve so that when you launch, it will hit all of the stars. And you do that by manipulating values. What this teaches is this shows students that each of these different values change a different part of the graph. So you can see here that I've moved my graph up. So that final value at the end changes where the graph is on the y-axis. I can also change my bounds, and that shows us how far the graph goes to the right. So if I launch it at this case, I've hit all the balls and I've succeeded in the graph. I can now click next and try one that's maybe a little bit harder and adjusting those values to see how the graph moves. This supports inquiry-based learning because students have to figure out a plan of how they're going to manipulate the graph, try it out, and then synthesize data and describe how the graph is actually changing. This is a beneficial skill for students to learn, and that you can use this activity to synthesize their own ideas of how to manipulate sine and cosine graphs. So using both the PhET simulation and Desmos, you've created this inquiry-based activity in math with a subject that's generally hard to understand, and students have been able to take control of their learning, engage in critical thinking. It's engaging, it's fun, it's a game, Marble Slide, how cool is that? But it's also challenging, and they're able to come up with their own rules of how to manipulate graphs. That is why ICT and inquiry-based learning, they lend itself well to each other, and I think that every class can use inquiry-based learning to develop and grow deeper conceptual understandings with the topics that you're discussing.